We're going to talk about a fuel cell here. So an electrochemical cell is something that uses a chemical reaction to provide an electric current. Most people would call it a battery, but really a battery is really when you've got several fuel cells linked together in series, but this is what it does. And a fuel cell is what we're going to talk about here. Right, so the hydrogen fuel cell uses this reaction. The reaction of hydrogen between hydrogen and oxygen to produce water. Now this is a very exothermic reaction. You produce 286 kilojoules per mole of hydrogen. And normally when you react hydrogen and oxygen together, if you lit it, there'd be a big explosion and you get all that energy be released in one fraction of a second as heat energy. That's not very useful. And what the fuel cell does is it uses the energy of this reaction to drive an electric current around. So instead of being kind of wasted as just heat, you can control it. You can have as much current flowing or as little as current flowing as you want. And it's a much more efficient way of using the energy. Right, so let's see how it works. Now it does say in the specification you do need to know the half equations. That's quite difficult. It's really kind of A level rather than GCSE, but because it says you need to know it, we'll go through it. Okay, so here's the fuel cell, and what you've got here is you've got an acidic solution, and these two things, these are the electrodes. Okay, now the electrodes are made out of a porous material, so it's got to stop. Well, what we've got here, we've got the acidic. It's got to stop the acidic solution leaking out, so it mustn't. It's going to stop that, but what it must allow is it must let the oxygen go through it, the gas to go through it, and the hydrogen to go through it there. Right, and it must conduct electricity, of course, because it is an electrode. All right, let's see what happens then. Right, so you connect, I'm going to connect an electrical wire, and let's say we've got a light bulb in that circuit. That's could be a motor or anything, but I'll just say a light bulb, make it easy. And what happens is electrons are pushed from this electrode around the circuit, showing the arrows there, and then they go back into this electrode. Now this one has got to be the negative electrode because it's pushing electrons away, and this one here where the oxygen reacts must be the positive electrode because that's taking electrons in. Right, let's see what happens at these electrodes then. So hydrogen gas, yeah, the fuel goes in here and then it can react at this electrode. And what happens is the hydrogen, H2, I'll do it here, H2, it loses 2 electrons. Each hydrogen loses an electron, so you form 2H plus, and you get 2 electrons, which then go around, are pushed around the circuit as I've drawn there. And what I'm going to do is I'm going to double that. You'll see why. So I'm going to just say, well, we've got 2 hydrogen molecules, so we get 4H plus ions, which of course H plus ions make the solution acidic, and we get 4 E minuses pushed around. Now, as those electrons are pushed around, when they get to the positive electrode here, what happens to them? Right, they're taken in, and the oxygen takes those electrons in, 4 electrons, and you also need some 4H pluses, yeah? They come from this acidic solution, the H pluses, and what's that going to make? Well, you're going to end up with, you count up the oxygen atoms, you've got 2, you've got 4 hydrogen atoms. And it's also important to notice that we've got 0 charge on this side of the equation because we've got 4 pluses and 4 minuses. So on this side of the equation, we make 2 water molecules, okay? Now, it's quite important to note here that if you look at this uses up hydrogen ions from the acidic solution. But the solution doesn't become less acidic because every time it takes in 4 electrons here, 4 electrons must be given out here, and look what happens here. It makes 4 H plus ions. So the H plus ions don't actually, the concentration of H plus ions in this solution don't change. And if you combine the blue equation with the red equation, you can probably see that what happens is, right, so if I do everything, I'm going to do 2H plus, and then plus from the product, so the reactants on the red equation, O2 and 4H plus, and 4E minus, and they go to, well, what products do we get on the blue equation here? We get 4H plus, and we get 4E minus, and from the red equation of the positive electrode we get 2H2O. So if I cross out anything that appears on both sides of the equation, so the hydrogen ions do, get rid of them, the electrons do, get rid of them, we can see that all we're doing then is we're reacting two hydrogen molecules with an oxygen molecule to form two water molecules. So that's what happens in the hydrogen fuel cell. And the loss in chemical energy, there's loads of chemical energy here, and there's not much chemical energy in water. The loss of chemical energy has been used not as heat as it normally is in an exothermic reaction, but it's used to push these electrons around. Okay. Now, with a normal battery, or cell, I should say, when you want to recharge it, what you do is you take this, you take the bulb out, and then you put a power supply in there, you plug it into the wall, whatever, and you'd make this the negative one and this the positive one, and you would push electrons back the way they don't want to go, and you reverse the chemical reaction. Well, that's not what you do here at all. What you do here is you don't, when you want to recharge it, well, you don't recharge it. You just leave it running all the time, and it will never run out as long as you provide it with this hydrogen, which is the fuel. That's why it's called a fuel cell. And, well, I suppose you can think the oxygen is a fuel as well, but the oxygen obviously is just coming from the air. Right, now the chemistry there is pretty tricky, definitely. So you don't, and any of the questions they've asked on this have been fairly easy. So even though in the specification it says you do need to know those half equations, if you think it's going to be not worth your while, this would be my take-home messages from about the fuel cell. Okay, so first of all, I would say, if you understand this, the first point, then we have got hydrogen reacting with oxygen to form water. That's very exothermic, and we use that energy to drive a current round. The good thing about this is the only waste product is water. So if you're using it in a fuel cell to make an electric car move, you're only producing water, which is obviously not harmful, unlike a normal diesel or petrol engine. So good to use in the city. I'd say I'd say that you must realize it's called a fuel cell because you don't recharge it, you just provide more fuel. Okay. But then you must realize that you may think, oh, it's perfectly green, the only waste product is water, but there is a problem. Where do you get hydrogen from? Hydrogen is not found uncombined in the earth ever. It's always in compounds, mostly it's in water. Okay, so where do you get hydrogen from? Well, you can do it from electrolysis of water, and you can get it from methane, but whatever way you do it, it nearly always ends up you having to generate CO2. So it's not really, it's not going to solve global warming and so on. There are problems with how you get hold of hydrogen. I suppose you could say you could make hydrogen from an electrolysis of water using a wind turbine, then it wouldn't make CO2, but there isn't an endless supply of hydrogen out there that we can just use. That's going to we can use it, get energy from it.